Okay.
Okay. Hi, Oren and Karen. This is Aditya. I work as a solution architect based out of Houston, and I'm responsible for NFP POCs in the Americas region. So the topic that we're going to discuss today is going to be a brief introduction to orchestration inside the NFV framework, and we're going to specifically talk about OpenStack Heat. I'm going to show you just a 5-minute demo of how Heat orchestrates things, and I'm going to give you a bit of a background about what Heat is and how it compares to NFV Director. So with that, let me go ahead and start presenting my screen. Okay, are you guys able to see my screen?
Yep.
Yep.
Okay. Okay, so the agenda for today, like I outlined a minute ago, would be a brief introduction to Heat, but mainly I'll be talking about orchestration inside the NFV framework. I'll talk about the architecture of OpenStack Heat, and then I'm also going to talk about differences between carrier class and data center based orchestration. And then at the end, we'll have about a 5-minute or so, a small demo of OpenStack Heat. And after that, we can take up any questions, if any. So you might be very familiar with this picture. This basically is the ETSI framework for having NFV POCs and for the entire NFV framework itself. And in this part, if you look at this right-hand side diagram, this is where we have the management and the orchestration layers, also called as the Mano layer. So what we have and what we have seen so far, and I'm sure my colleague Vishwa would have talked about it yesterday, is we have one view which is here, which is basically acting as the HP converged infrastructure piece, on which we have the entire HP VNF ecosystem, wherein all of the VNFs are onboarded and they are orchestrated. So what does orchestration mean in this context? So since we have infrastructure which is set up and we have HP Helion OpenStack which is installed and is acting as the virtual infrastructure manager, what we now need is we need a mechanism for onboarding VNFs onto your virtual infrastructure platform. And for doing this, we have two mechanisms. One is HP NFV Director and the other is OpenStack Heat. So once you have a VNF, which can be a VM or a set of VMs, for onboarding that onto your virtual infrastructure platform, you need to create an environment for those VNFs. Now, this environment can be basically a set of VMs which are created on a set of networks. It might have specific routing needs, and hence you'll need to have routers created. You also might have some fixed IP, some DHCP pools, and some floating IPs associated, and all of this. And for doing all of that, there are two mechanisms of doing it. One is that you have NFV Director, which is an NFV orchestrator and a VNF manager. That is, it understands all that a VNF needs, and it can go ahead and call individual OpenStack calls. So the direction is this way down, wherein you have NFV Director, it understands the VNF needs, and then it goes and talks to Helion OpenStack to go in and create those individual components. So these individual components, like I outlined earlier, can be networks, subnets, routers, floating IPs, fixed IPs, DHCP pools, and so on. Or the other way around could be that you let OpenStack do its own orchestration, and you just talk to one layer called OpenStack Heat. So OpenStack Heat would then come into the picture and would orchestrate everything that is needed for the VNF to be onboarded, and that would be at the OpenStack layer itself. So that NFV director, now instead of talking to individual components, and I'm sure you would have seen over the last day or so, you would have seen Nova Neutron and all of these different calls and all of these several components of OpenStack. Now NFV director now has a choice to talk to all of these individual components like say Keystone, Nova, Neutron, Glance, and all of that, or it can talk to one single uniform interface called as OpenStack Heat. So OpenStack Heat provides a uniform interface to NFV director so that the orchestration at the OpenStack layer is done by OpenStack Heat, and the carrier level orchestration will be done at the NFV director level. So this is a brief introduction to orchestration in the NFV framework. Now, since our topic of interest is actually Heat itself, I'm just going to go and talk about Heat briefly. So the architecture of Heat is like this. Heat has a REST API, which is called by any northbound interface. Now this Heat user interface here can be a Heat template. It can be a Horizons dashboard itself, or it can be a northbound piece like NFV director. So Heat API is basically called by a northbound user interface. So what Heat REST API does is it talks via a message queue to Heat engines. Now there can be several Heat engines, but for our purposes, we'll just take one Heat engine. So whenever a template is created and the Heat REST API is invoked, it will talk to the Heat engine to go ahead and call a workflow service. Now, remember that this is orchestration, and what happens is that in any orchestration, you will have a series of steps, and each of these steps basically perform one singular action. So the steps inside of a Heat template would be a series of steps, and the steps inside these Heat template would be individual OpenStack API calls. So that is what is depicted right in the bottom. So you have a REST API which is talking to a Heat engine, and the Heat engine is actually calling a workflow service, which will then invoke individual OpenStack APIs. And after this workflow is created, it's going to store the state inside of a Heat database. Now, this side on the right is what I would like to call a pluggable infrastructure. So basically, everything that you see on the right hand side can be basically plugged into Heat, so that Heat can make the entire life cycle much better. So for example, what I'm showing here is actually a monitoring piece. Now this monitoring piece that you see here consists of metrics and alarms. So Heat can be used to go ahead and create a VM and create a router and a network and so on, and you can plug in a monitoring piece into that framework, so that if you have say the utilization of the CPU utilization of the VM hitting a certain threshold, Heat can be automatically invoked so that it can go ahead and take some kind of a remedy action. So Heat also has it has a pluggable interface for you to include any kinds of metrics and alarms, so that upon an alarm you can actually go ahead and take an action. So Heat is actually the main project inside of the OpenStack orchestration program, and what Heat basically has is like I told you earlier, it has an orchestration engine which is basically responsible for deploying all your templates. Now what is a template? A template basically specifies the relationships between all of the individual resources that are contained within itself. Now these resources can be any of the individual OpenStack API calls themselves. So if you have a series of steps which would involve, say, the creation of a VM, creation of a network, creation of a subnet, creation of a router, assigning of a floating IP, all of these can be contained within the template, and you can specify a particular order in which all of these are invoked. And then what would happen is that you would have these series of steps invoked in that same specific order that you have specified, and all of this would be orchestrated to you within the matter of minutes. So you don't have to individually go and create those components, but then you are just handling one heat template itself. So so I'll just get you familiarized with the various terminology that is there here. A heat template is actually a collection of resources, and these resources are individual OpenStack calls themselves, and each instantiation of a heat template is called a heat stack. So a heat stack is one instantiation of a heat template. The template actually provides you with the blueprint. Now, and as I outlined earlier, Heat also has the capability to plug in with several monitoring and metric tools and so on, so that they can actually provide Heat with what they know best, that is the metering and the monitoring part, and you can take an action upon an alarm, which can also be specified inside the same Heat template, and this makes the Heat template pretty self-contained. Now, in the context of NFV Director, Heat, like I told you before, is going to give you a uniform not-bound interface, so that you don't have NFV Director talking to 10 different OpenStack components, but instead you will be having one component itself. So the other thing that I wanted to talk to you about was that we have two different orchestration engines here. We have NFV Director, which is going to perform carrier class orchestration, and we have a data center orchestration called Heat. Because remember, Heat is still part of OpenStack, and OpenStack is still contained within the same data center today within Helion OpenStack. So when you have two layers of orchestration, NFV Director and Heat, I just wanted to outline the differences between data center orchestration and carrier class orchestration. So for data center orchestration, all the resources that it talks to are equivalent. So Heat does not make a distinction between, say, a VM or a network. For the purposes of orchestration, a VM and a network are pretty similar in that it treats both of them with a certain amount of neutrality, and it goes ahead and provisions both of them equally. But for a carrier class based orchestration, this will not cut it, because the actual location of the resource that it is orchestrating matters a lot, and you cannot have the same treatment being meted out to all of the resources that it deals with, because of the sheer bandwidth and the latency considerations that it needs to have. And like it is self-evident by now, data center orchestration like Heat is basically within the same data center, whereas a carrier class orchestrator like NFV Director or any other orchestrator will have to deal with several data centers, and it can be across a metro area. So, so data center orchestration is actually tied directly by the user, and it is controlled by the user. So an individual user can go ahead and request for a heat stack being created, while a carrier class orchestration is linked into higher level BSS and OSS systems. So the monitoring that I was talking about is still pretty fine-grained inside a carrier class orchestrator when it is compared with a data center orchestration. So a carrier class orchestration has to look into very, very fine behavior, like say transactions and so on. So for example, if you have a VNF which is going to perform say 30 calls or 40 calls, or it is actually expected to perform a certain call rate per minute or per second, and if it is not performing at that level, then we'll have to take some action against it. Now this is the level of monitoring that is needed within a carrier class orchestration, whereas for data center orchestration right now, all that you get is CPU and memory and disk and IO and bandwidth and so on. So in that sense, it is pretty coarse status monitoring. So the other and the final point that I would want to make here is that all the resources for a data center orchestration are actually elastic. So I can have 2 networks instead of 1. I can cut down the number of networks into 1 instead of 2. I can have 4 VMs, or I can also make that 2 VMs or 6 VMs. As and when required. But then for carrier class orchestration, it's actually a set of VNFs which is being deployed, and it's not just one VM or one network. And hence, the entire VNF has to be elastic instead of individual component being elastic. So it's a much higher level of abstraction that we're talking about. So with that, I've just covered a brief of what NFV Director might do in the future, and you'll get into much more detail into NFV Director over the coming days or hours. And what I'm going to show you now is a small Heat demo. Before that, I just want to show you a few screenshots of how Heat looks like. So within your Horizon console, Heat stacks. Now, remember, a stack is actually an instantiation of a template. A Heat stack is there in this panel here, and you can see the individual stacks which are created. And for doing that, you can actually go ahead and select a template by creating a stack. So the launch stack button here inside of Horizon is used for launching a stack, and you can specify a template file, and you can specify an environment file. So to pass parameters into Heat, you use something called as an environment file. An environment file basically consists of a list of parameters, and you can pass all those parameters into the template for doing the instantiation. So with that, I'll just show you the Heat template that I have. So you see here are the list of parameters, and these are the parameters that I'm going to pass into my Heat template. So what you're seeing here is actually a Heat template, which is based off something called as Heat orchestration template, or HOT. And this Heat template is basically used to go ahead and provision a set of resources. Now, what does this Heat template do? This Heat template creates a network. It then attaches a subnet with that network, and each of these resources that you're seeing get several parameters that we have seen above. So it takes a net name as an input. It takes a tenant ID as an input. It takes a provider network type. Now this can be VXLAN, or it can be GRE, or it can be any of the, it can be VLAN and so on. And then after the network is created, it is going to go ahead and create a subnet. Now, what I have here is actually a dependency called as Heat internal network. So what this means is I cannot create a subnet before this resource, that is Heat internal network, is already created. So this is to showcase that within Heat, we also have the capability of forming dependencies as well. The next thing that this Heat template is going to do is it is going to create a router, and it is going to attach an interface to the router. Now the router's interface is going to be this network that has been created, and this router is actually going to go ahead and attach itself onto the external network, which is going to act as a gateway. Now, what we have created so far is one router, and that router's gateway is the external network, and that router on the internal side is going to have the Heat network which is created. Then what we're going to do is we're going to go ahead and create a Heat instance, and this Heat instance is going to basically go ahead and create a VM, and it's going to place it in one specific availability zone called AZ1. So note that all of these different parameters are being passed via an environment file. In the end, after the VM is created, I'm going to associate a floating IP with this VM, and I'm going to use that floating IP to log into that VM. So I'll just show you the master environment file that I have here. And here I'm specifying a tenant ID. I'm having an instant name. So I'll just make it CentOS demo. I have an image which is specified, and this image is going to be a CentOS image. I'll create a network, and I'm going to call it demo network 1. I can specify a type of network, and this is VXLAN right now, and I have to specify a segmentation ID. So if I specify something like, and I have to specify a demo subnet and a CIDR for the subnet. That I'm going to use is going to be heat stack create, followed by the environment file that we have just edited, followed by the template file that I'm going to create, and the stack name. So I've already created a stack for you, and then I'm going to create an additional stack right now. So let me just go ahead and show you the stack resources that are there inside this stack. So we see what we have seen earlier. We have a network, we have a subnet, we have a router and a router interface, and we have a server and a floating IP. Now, if we go ahead and look at the list of VMs that are being created, we see that the CentOS demo VM that we have created is still going on, and that is going to get created, and you'll see that it will not only have a fixed IP, it will also have a floating IP like the VM that I've created here. So meanwhile, I'll just show you what has been created inside of a network topology. So you see that demo net is what I had created. It is attached to a heat stack router, and there is a VM which is attached to that network. So we can go ahead and log into the VM as well. Now you see that both of them have a floating IP. Earlier it did not have a floating IP. All of this is orchestrated by heat. So if I just go ahead and log into that VM, we see that the VM has already been created. So if you go in and see, you will have two instances created, CentOS demo, which was just created a minute ago, and this was something that I had created earlier. So these have a specific flavor which was given, and all of them have an availability zone which is also provided. So I can go into so this is a newly created one, and this is the old one. And if I log into the console from here, running, and it has one NIC configured onto the newly created subnet that we have. So this actually ends my demo and my presentation as well. So if there are any questions, I'll be happy to take them.
No questions. Thanks.
Any question on my side, if I may? I don't know, Alita, if you know this tool that we were presented this morning called the VNF Onboarding Wizard.
Okay.
Do you know this tool?
I'm guessing that this is going to be part of NFV Director and their team. But apart from that, I'm not very aware of that.
Okay, because this morning I think they created those environment file, YAML file, and so on. So it's probably something that is used by the NFV BU to simplify the creation of those files. Perfect.
Yes.
Okay.
I think I would agree. Yeah.
Okay. If there are no more questions, then let's stop here. Thanks again for the demo and the slides. If you could be sending me this so I can share with everyone, would be good, Alita.
Sure, Stefan. Yeah.
Okay. Thank you very much.
Yeah. Thank you.
Bye-bye.
Thank you, guys.
Bye.
Yeah.